So our discussion of empirical formulas will be fairly short, since we just did this last year. The idea is to come up with the subscripts that relate the lowest common multiple of the moles of atoms of each of the elements in the compound. So we have carbon, hydrogen, and oxygen, and we're looking for the whole number ratio of those elements. So remember, the first thing we're going to do is assume that we have 100 grams of our sample if we're dealing with percentages. If we assume a 100 gram sample, then we would have 44.77 grams of carbon, 7.52 grams of hydrogen, and 47.71 grams of oxygen. Next, we would convert these into moles. 1 mole of carbon, 12.01 grams. 1 mole of hydrogen, 1.01 grams. 1 mole of oxygen, 16.0 grams. This gives us 3.73 moles of carbon, 7.52 moles of hydrogen, 2.98 moles of oxygen. You do need to be careful about rounding here. We want to try to keep as many significant figures as we can throughout the problem until we get to the very end. Once we figure out moles, we're going to divide by the smallest number of moles, which in this case is the 2.98 moles of oxygen. That gives us 1.25 moles carbon, 2.52 moles of hydrogen, and 1.00 moles of oxygen. Now at this point, we don't have whole numbers still. So we're going to have to, at this point, multiply by a number. So we're going to multiply by 4. And remember, the multiplication at this point should be a simple whole number. It should be 2, 3, 4, at the most, probably 5. So if we multiply the first one by 4, we would have 5.00 moles of carbon, 10.08 moles of hydrogen, and 4.00 moles of oxygen. And obviously at this point we can round to 5, 10, and 4, so we end up with an empirical formula of C5H10O4. To get from here to the molecular formula, so the actual formula of the molecule, we also need to know the molar mass. Now this is a fairly simple calculation for us. So if we're given the molar mass, we would take the molar mass, 268 grams per mole, and we would divide that by the empirical formula mass. So the empirical formula mass for 5 carbons, 10 hydrogens, and 4 oxygens is 134 grams per mole. The empirical formula mass. This ratio is equal to 2, which means that our true molecular formula is twice the empirical formula. or C10H20O8. So one molecule of the substance would actually have this formula. In this next type of analysis, in order to determine empirical formulas, we're going to take a substance, menthol, and combust it inside a chamber. The chamber looks something like this, where you would burn your sample inside this furnace. The product of that combustion reaction, with the oxygen flowing through, would then go through this series of filters. So we've got the copper 2 oxide filtration, followed by a water absorber and a carbon dioxide absorber. Each of those filters would be weighed before the reaction and after the reaction to determine the amount of carbon dioxide and water that was produced. What we'll end up doing then is use stoichiometry to figure out the moles of carbon and the moles of oxygen, the moles of carbon and the moles of hydrogen, and then we'd have to do a little bit of manipulation with the data for the mass of the original sample to figure out the mass of the oxygen. So I'm going to get you started on this one, and then I'd like you to finish this one up on your own. So first of all, the reaction, we would have the compound containing carbon, hydrogen, and oxygen. And we're starting with 0.1005 grams of that compound. We'll be reacting it with an excess of oxygen gas, producing CO2 and H2O. So the mass of the CO2 was 0.2829 grams. That's the mass of the carbon dioxide that was produced. And the mass of the water produced is 1.1159 grams. So obviously all of the carbon in the CO2 came from the original compound. Same would be true of the hydrogen in the water. All of that mass came from the original compound. So use a little bit of stoichiometry to work backwards and figure out the grams and moles of carbon and hydrogen in your original compound. And then you can use that to figure out how much oxygen must have been present in that compound, and then follow up doing your standard empirical formula problem. So work that problem out and bring it with you to class so we can talk about that, and then we'll do more practice on these, probably do 2 or 3 of them in class for review.